In this video, I'm going to cover section 10.2, which is about exponential decay. This first problem comes from the homework, and it references an article that I'm going to show you on the next slide. It says, as noted in the article on the Shroud of Turin, radiocarbon dating analysis concluded that the shroud was made in the 14th century. Assuming that the shroud was made in 1365 AD, how much carbon-14 did it contain when it was tested in 1988? All right, so here is the Shroud of Turin. This is the cloth that they believe that Jesus was wrapped in. Right, so you can see the impression that it left. I'll give you a second. You can pause the video if you would like to read this article. So we're going to try to figure out how much carbon-14 that the shroud contained when it was tested in 1988 if we assume that the shroud was made in 1365. Recall that we have this formula for the quantity Q of carbon-14 remaining T years after the death of an organism that had an initial amount A. So there's the formula. Q equals A times E raised to the negative 0.000120968 T. Since we don't know the initial amount of carbon that was present in the shroud, the only thing that we can calculate is T. Right, so we're going to try to calculate the time that has passed. Now this should be pretty easy to calculate given that we know that the shroud was tested in 1988 and that the shroud was made in 1365. So we'll just do 1988 minus 1365. That's going to give us 623 years. Right, so now we know that T equals 623. Now let's plug in what we know, which is T. All right, so plugging in T equals 623, we have Q equals A times E to the negative 0.000120968 times 623. I'm not going to multiply that out just because I know it's going to give me a long decimal, so I'm just going to leave it like that. But what I need to do now is I need to divide both sides by A. This way we have everything that we don't know on one side, and we can just plug the right-hand side into our calculator. All right, so dividing both sides by A, that's going to cancel out the A's on the right-hand side. Now we're left with Q divided by A equals E raised to the negative 0.000120968 times 623. Now you're going to go ahead and plug the right-hand side into your calculator using the E button. And here I have just a screenshot of what that should look like. So we're left with Q divided by A equals, and I've rounded it to 3 decimal places, so that's 0.927. Now I need to convert that into a percentage because that's going to tell me the percent of carbon-14 that was remaining. So moving that decimal 2 places to the right, that tells us that in 1988, the Shroud of Turin contained 92.7% of the original amount of carbon-14 expected in a living organism. Now we have part B to this question. It says, again, as noted in the article in the Shroud of Turin, radiocarbon dating analysis concluded that the shroud was made in the 14th century. However, let's assume that the shroud was made at the time of Christ's death in 33 AD. How much carbon-14 should it have contained when it was tested in 1988? All right, so the only difference in between this problem and the problem we just did is the number of years that have passed. So we need to recalculate T. Remember, T tells us how many years have passed. All right, so therefore, instead of having 1988 minus 1635, this time we're going to have 1988 minus 33, which is going to give us 1,955 years. All other calculations will be exactly the same. I'm going to give you a chance to pause the video now, and then you can check your answer and make sure you get the question right. And here is the answer. If the shroud was made at the time of Christ's death in 33 AD, 78.94% of the original carbon-14 will remain. And I think it looks like they wanted one decimal place, so I should have left that as 78.9%. Here we have a different problem. This time, you're going to be given some of the same information, and then we'll be given a little bit different information. We'll have to figure out where we put that information in at. So this problem concerns the Dead Sea Scrolls. It says the first of the Dead Sea Scrolls were discovered in 1947 in caves near the northwestern shore of the Dead Sea in the Middle East. The parchment scrolls, which were wrapped in linen and leather, contained all the books of the Old Testament except Esther. An analysis showed that the scrolls contained approximately 79% of the expected amount of carbon-14 in a living organism. So using that information, we're going to determine the age of the scrolls. Here I have a picture of the Dead Sea Scrolls. All right, so we're going to use that formula that we used in the last problem. So we have Q equals A times E raised to the negative 0.000120968 times T. Remember, Q is the quantity remaining, the quantity of carbon-14 remaining. A is the initial amount of carbon-14 that was present, and T is the years after the death of an organism. So we have to manipulate this formula a little bit. We'll algebraically manipulate it so that we can use what we know. So what we're going to have to do is divide both sides by A, so that we can use the fact that we know that the scrolls contained approximately 79% of the expected amount of carbon-14. So dividing both sides by A, we get, now similar to what we did last time, we're left with Q divided by A equals E raised to the negative 0.000120968 times T. Now we're going to replace the Q of A with what we know about how much carbon was left in the organism. All right, so it says, since we know that the scrolls contain approximately 79% of the expected amount of carbon-14, the first thing we need to do is change that 79% to a decimal. So 79% as a decimal is 0.79. We're going to replace Q divided by A by 0.79. Now, to get T by itself, since T is in the exponent, we need to take the natural log of both sides. Now, this is something that we learned in class, and we learned that natural log and E are inverses or opposites, and they cancel each other out. So here we've taken the natural log of both sides. Remember that natural log and E cancel each other. So we're left with natural log of 0.79 equals negative 0.000120968 times T. So everything that was in the exponent has now come down and it's become our right-hand side. Now the last thing we need to do is just get T by itself. So we're going to divide both sides by that coefficient of negative 0.000120968. Then go ahead and plug the left-hand side into your calculator. I've got a screenshot of what that should look like. And thus, now we can see that the Dead Sea Scrolls are approximately 1,948.6 years old. In 1947, that's how old they were. If you have any other questions about exponential decay, please feel free to email me. Otherwise, I'll see you guys in class.